Okay, this is 3-2, TEKS 3B, solving systems of linear equations with 3 variables. So again, I'm using the numbers system of 1, 2, 3 to identify the actual equation I'm looking at, not for any other purpose. There's a couple of ways we can do this. I'm going to show you the 2 harder ways, and I'm going to show you how to use it on the calculator using what's called a matrix. So we can also use substitution, and we can also use elimination, just like we did with 2 variables. So first we need to choose one of our equations and a variable to eliminate. We're going to try to eliminate y from this equation, or solve for y for this equation. And again, we're going to take all of the pieces that are not y and move it away from the y. So dividing out our equation, we can say, okay, I need to move the positive 2x on this side, and I need to move the negative 3z on this side. That will move x and z away from y, leaving z by itself. Okay, or leaving y by itself. So we bring down our y, and that is now equal to 2x minus 3z plus 20. And we can't add any of those numbers together because they all have different backings behind them. X, z, and 20 are not the same. So now we're going to take what we just found out y is, and we're going to replace it for y in both the second and the third equation. So we're going to do it twice. So negative 3x plus 2 times, we'll put in the 2x minus 3z plus 20, where y was, but then we're not losing any of the original equation outside of that. So all of the other components have to come down. Now we can use, in this case, a triple rainbow, and we get 3x plus 4x minus 6z plus 40 plus z is 21. And now we want to combine things that are the same. So x's, the z's, and we can go ahead and move our 40 to combine those numbers. Okay, so that gets rid of the 40 on this side. Negative 3x plus 4x is positive x. Negative 6z plus z is minus 5z. And negative 21 plus 40 is negative 19. So now we have that equation. Okay, and we're going to do the same thing on the other side. We're going to say 3x minus 2, put in our y where it belongs, what it's equal to, 2x minus 3z plus 20. Again, none of that changed from what we had done before. And I forgot to write the equals. So that equals, this is negative 9. Sorry, I thought I had prepared. Come on, negative 9. Okay, so now we're going to do, again, the triple rainbow. And we get 3x minus 4x plus 6z, and then minus 40 plus 3z equals negative 9. And again, we're going to combine things that go together and move anything that is a number to the other side. So we're going to add 40 on both sides. So our 3x minus 4x gives us negative x. Our 6z plus 3z is 9z. And that equals negative 9 plus 40, which is positive 31. Okay? So now we're going to take those two equations and we're going to do some manipulating with them. So we're going to take our fourth equation, which was the first one we solved for, and we're going to solve it for x. So again, we're going to move anything that is not x away from x. So we're going to add the 5z to the other side, but again, you cannot add the 5 to the 19 because they are two different groups. So x is positive 5z minus 19. And now we're going to take and substitute what we have for x, 5z minus 19, into the fifth equation so that we can solve for z. So we're going to take 5z minus 19 and replace it where the x is. That negative is going to stay. It it's going to stay there, and we're just going to put in the 5z minus 19 where x was. Everything else about this equation has to stay the same. Now we will do our double rainbow. Negative 1 times 5z is negative 5z. Negative 1 times negative 19 is positive 19 plus 9z, and equals 31. Get things together that go together and move numbers away. So negative 5 plus negative 5 plus 9 is positive 4z, and 31 minus 19 is 12. And now we need to divide by 4, so we find out our z is 3. Okay, now that we have z, we can start moving our way backwards. We're going to plug 3 in to where it is in the previous equation, or the fourth equation. That way, if we made a mistake on the fifth equation, we'll catch it here in this one. X minus 5 times 3 is negative 19. X minus 15 equals negative 19. And then again, we're going to get x by itself. So we're going to add 15. And we find out that x is negative 4. Now we take both of those numbers and we're going to plug them into where they belong in the one of the original equations that was given to us. I think this is problem equation 1. So negative 2 times negative 4 plus y plus 3 times 3 equals 20. 8 plus y plus 9 is 20. 8 plus 9 is 17. Plus y is 20. So we're going to solve for y. Subtract off the 17. And we find y is 3. Okay? So our final answer is a combination of all three of those parts. So x was negative 4, y is 3, and z is 3. The whole part, that whole thing is the answer. Okay, so that's using substitution. As you can see, it takes many steps. The next option is elimination. So this one is a little bit complicated. You would need to first eliminate a letter off of from 1 and 3, and then also from 1 and 2. It's important that you choose one of the equations to be this is going to be in both my eliminations. So I'm picking equation 1 to be the one that's going to be connected to both the other two. And then we will pull the results together for the next step. So again, we're trying to get rid of z, and in this case, we just need to multiply one of the two pieces by negative 1 so that we can change one of these 3's to a negative. It's usually best to do the second one. Okay, so what we end up with is the same first equation, but the second equation, everything is being changed to its opposite sign. So negative 3x, positive 2y, and negative 3z. And then negative 9 times negative 1 is positive 9. Now we're going to add down, and when we do, obviously z is going to go away. So negative 2 plus negative 3 is 5x, negative 5x. 1 plus 2 is 3y, that's 0. And 20 plus 20 is 29. Okay, so now we're going to do the same thing to equations 1 and 2. We're going to eliminate z, and this time we need to multiply the denominator, or the second equation, by negative 3 in order to eliminate that 3. 43, and I was right down here to begin with. Okay, so now we're going to try to eliminate the y's, and again, this time we're going to have to multiply the top and the bottom equations by the least common multiple. So the 3's times tables and the 5's have 3, 6, 9, 12, 15, and 5, 10, 15. So the 15 is what they have in common, and that's what we're trying to change the 3 and the 5 to. So first, we have to multiply 3 times 5 to get 15, and 5 times 3 to get 15. So that's what we're going to do. So 5 times negative x, it's negative 5x, plus 15y equals 140. And then 7 times 3 is 21x, negative 15y, and negative 129. Okay, now we can add down. That adds the 15s to 0, and that leaves 16x equals, okay, and then we're going to divide by 16, and x is 1. I don't know, a whole lot of that. Okay, our next step is we're going to substitute the x that we've just found, 1, and where it was in the fourth equation before we did any changing. And then we're going to solve for y. So add 1 to both sides. 3y is 30, and then we divide by 3, we get y is 10. Now we're going to substitute both of those, x and y, into where they were in the first equation. Okay, so we're going to substitute into the first equation the original equation that was given to us. So negative 2 times 1 plus 10 plus 3z is 20. And now we're going to solve for z. So negative 2 plus 10 adds up together to be 8, plus 3z is 20. We want to get 3z by itself, so we're going to subtract off our minus 8. And that gives us 3z on one side, because the 8's go away, and 12 on the other. So we divide by 3, and we get z is 4. So our final answer here is 1, x is 1, y is 10, and z is 4. So it's always going to be in that x, y, z form, alphabetical order. Okay, the last way we can do this is by using solving within a graphing calculator, or actually not the graphing calculator, a matrix on a calculator. It's a special feature in the calculator itself. One of the things that's very important is all three of our equations have to be in x, y, z order. So all the x's have to be in line, all the y's have to be in line, and their signs, and all the z's have to be in line. And then everything after the equal sign are always going to be single numbers. So that's important. A, B, C order, and negatives have to go with the numbers they had. So our steps is we would go onto our calculator in the calculator mode and push menu 711. And then you would have to tell how many rows you have and how many columns. So rows is figured out by the number of equations you have, and columns is figured out by one more than the number of variables you have. So if you have 3 variables, then columns is 4. If you have 3 equations, then rows 3. And then you push OK, and you would type in the numbers, but not the variables. So 2, 1, 3. So basically, when we write our if we wrote these down, we would take 2, positive 1 that's in front of the y, 3, and then 20. And then the next would be 5, 2, 1 for z, and then 21. And then our last one would be 3, negative 2, 7, and 9. And that would give us our matrix, and that's exactly what you type into your calculator. Very important you make sure that you don't forget any minus sign becomes a negative and attaches to its number. Then you push menu 7.5, use the up arrow to go highlight the answer from the previous answer, and it will immediately put it and hit enter, and then it will immediately put it inside your RREF parentheses. And then you hit enter again, and what it will print out is this information here. It's real important that the pattern that you see here, 1, 0, 0, 0, 1, 0, 0, 0, 1, it must look like that for the XYZ answers to be these 3 to be the XYZs. If it doesn't look like that, then it's either a no solution or an all solution. So our answer in this particular problem was negative 1 over 24 is your X, 209 over 24 is your Y, and 91 over 24 is the Z. So solution types that you need to be aware of is if it does have that pattern where it's 1's going down into the diagonal with 0's around it, then it is XYZ. Those are your answers, X, Y, and Z. If it has numbers going straight across and a number for X, but then everything below it is zeros, that's an all solution. If it has numbers going over with equal to zero, same numbers going over to equal to zero, or different numbers, and then all equal to zero. So these two are zeros. And then the last one says 0 equals 1. What that's trying to say is this one's trying to say 0 is equal to 1. So that's a no solution. 0 equals 0, 0 equals 0. That's all solutions. Numbers, one's going in all the directions because on a matrix, the first column was your x column. So if you have a 0, 1 here, that means 1x equals whatever the number is that ends up being the answer in the C column, or excuse me, D column, x, y, z. So, and this one says that the y is equal to whatever that number is. And the last one says the z is equal to whatever that number is. So that's how you read this. If it doesn't have one number, one here, and then nothing, zeros here with a number, then obviously we do not have something equal to that x answer. This one is saying that an entire line is possible, and that means all x's and all y's and all z's can be put in, and it will give you an answer. Okay, finally, we're going to look at the worksheet. These are just showing you the answers. So on the first problem, I used elimination. I tried to eliminate the x's. So I took the first equation and the second equation, and I multiplied the second equation by -2 to add the 4 or the x away. And then we ended up with 5y plus 10z equals -5. In the second equation, we took the second and third problem and did the same thing. And then we combined them. And what ended up happening was they ended up eliminating the y and the z also were eliminated. So we ended up with 0 equals 0. So all solutions. On the second problem, I did the same thing. I used elimination. And then once we combine them down to together, we end up with 0 is equal to -79, which cannot happen. So that's a no solution. So on the last two questions, we are going to use a graphing calculator, and I'm going to demonstrate them. I need to do some adjustments on the screen real quick. So I wanted to show you step by step doing the calculator steps. Real quick. All right, so first thing we need to do is to write our matrix on paper. That way we know exactly what to type into the calculator. So we would go to, on the calculator, you would go to a calculator, and then we're going to write down our matrix, which would be 4, 1 for at y, 3, and then 22, and then 3, -5, -1, and 28, and -4, -4, 2, and -16. So again, we're dropping off the letters because they technically are the labels for these different, each column. So now on the calculator, you'll go to menu, 711, 711. There are 3 equations, so we're going to say 3 for the number of rows, tab, and there are 4 columns, or 3 variables plus 1 is 4. And now we're going to type in just our numbers using the arrows to get between the different groups. So 413, 22, and then come down, do 3, use the negative key, which is the black key, for the -5 and the -1, and 28, and then -4, oops, 4, -4. If you make a mistake or you get an error message on your matrix, it's not coming out to what you're doing, make sure you double check your negatives. That's the number one area you'll make a mistake on, is not putting in a negative when you should have had a negative, or not putting in 1 or 0. 1 goes in if you do see the letter, the Y. 0 goes in if you are supposed to see a Z or something like, or an X, and you don't. So then you do menu 7.5. You're going to use the arrow to go highlight the previous, what you just got as an answer. Hit enter. It will copy it, and then you hit enter again, and you get your answer. So this one, we put RREF in front, and this equals 1006, 010, -2, 0010. So what that equates to is 6, -2, 0. That's your X, your Y, and your Z. Okay, so one more example. Okay, so last example, I have already put in the matrix. You see the matrix here, how I put it into the calculator, RREF'd it. And RREF means reduced row echelon form. It's a series of steps that you don't need to worry about knowing how to do. But when you get the answer, again, you get 2, -1, -1, which is your X, your Y, and your Z. Okay, that is all of these notes.